Okay. Um, so let's finish up this creating frequency distributions page. So one type of graph that I want to make sure we mention is a time series graph. It's unrelated to the categorical data and the numerical data. A time series graph is significant because it's connected to time. An example of this would be these two time series graphs. They're actually over the same set of data. So this is the life expectancy for different years. These two examples are actually from the chapter on misusing data. This is a bad graph. It can be used, it's not clear. And the reason it's not clear is that instead of starting at 0 like this one does, where you see, oh, life expectancy really hasn't changed that much. By zooming in and starting at 74 on the bottom, which if you aren't sharp, you might not notice. Side note, when you're reading graphs, look really carefully at all the details. This graph, even though it could be misleading, is still true. It's not false information. This is a graph of this data. So you might see something like that in some sort of news publication. This is the kind of thing that somebody might use to try to convince you of something. To convince you that, whoa, the life expectancy is just shot up. Look at this graph. But really, this is just a zoom in from age 74 to 79. It's just a 5-year span. Which, if that graph was included and it was clearly said, note, this is just 5 years, but hey, that's 5 years! That's why it's really important to look carefully at the details. But we're just introing a time series graph here. Time series graph uses a time along the bottom, and then whatever that data is as time has progressed. And you see how it happens like a timeline. Goes up or down over time. That's time series graph. Now let's look at our last thing on this worksheet, a stem plot, or otherwise known as a stem and leaf graph. This is another way to organize numerical data. We're going to look at data from page 325. So this data is from page 325, number 4. And we want to put all this into a stem and leaf graph. This looks like it is numbers of registered vehicles stolen for 35 selected cities in the United States. So let's graph it. So the way a stem and leaf graph works is we've got 2 digits here. You pick the big digit, and that becomes the stem. And then all the little digits become the leaves. So the number 38, I started this here so I could get my text box in place. 38, that would be represented by 3 is the stem, and 8 is a leaf. This next number right here, 41, well, the 4 from the 40 would be a new stem, and 1. Then we have a couple of 50s. So the 5 there, and I've got 2 zeros because there were 2 50s. Now with a stem and leaf, you don't have to write it in order. Your stems could actually be in whatever order you want. As we come on down after 50, we've got 92. And then we're back up to 53. So this 53 right here, add a 3 there in the 50s. 58, so we'll put in an 8. So far everything is in order until, ooh, we've got to a 70. Well, if I want to, I could just put that 7 down there. It's okay if it's out of order. There's 2 of those 70s. There's an 84. Then we're back up to this 53, so stick on another 3. And those are out of order too. That's okay. You just gotta have everything on there. I kind of like it in order, but you don't have to. That's stem and leaf. So I'd go through and I'd do that for all of them. If you had 3 digits, then you'd put the 100s place as the stem, and then 10s and 1s as the leaves, with like commas after each thing. Or if you had 3 digits, but they were all really close in together, like 341 and or 345 and 347, and they were all in the 340s or 350s, you might make the first 2 digits, like 340 be the stem and then 1 be the leaf. I don't love this method, honestly, but now you know it. I should point out that I did not finish this. I did not get to all this data, but you just carry on adding them up. And that's the stem and leaf.